Hi, right, it's Keith. Trying to do a lot of more advanced videos. So if you're following some of the training thing, it's more advanced. But what we're just coming into the UK market and we've got this baby. This is actually one of our newest inverters. We've had it for a while. This is a 3.6 with a 7 kilowatt MPPT, but it's much smaller. It's much more compact. It hasn't got cooling fans. And I just wanted to show a few things about the setup. We've added lots and lots of new features onto it. So let's just look at the setup, very simple. I did on a video earlier on. We're connecting into the battery. So we've got here, which is the live on the battery, neutral to neutral, using a Sunsynk battery. Connect it to the CAN here, or the RS485, it's the same port. Because it's a single battery, all the dip switches are set off. We connect it into the CAN. Here, it must go into the CAN connection. Don't forget on the cable, and if I unplug the cable, you'll see the cable has two directions, two markings, and one says, you see on the engine, it says BMS, and there's PCS. The BMS is the battery management system, so the BMS must go into the battery. Look at the settings on the inverter. Go to battery, we select lithium, we select 0, we select CAN, we press OK. We go on to lithium ion and you'll see the figures here. If you don't see that here, with this very simple check, battery, lithium, you can see here the setting, here, CAN, 0, okay, check on here, check the fittings. Very, very important. If you don't see that figure and if you don't see that information and you haven't got communication, if you simply plugged it into the CAN and you plugged it into the unit, it will work. It will work. The only reason it won't work is if the cable's damaged or something stupid like that. So it's not a problem. So that's the first point. There's lots and lots of things obviously going on here, and the units changed. If you look on the connectors here, we look inside the units because obviously this is quite important. You have here, I'm using my electrician's pointer, so electricians is a screwdriver. Everything we do is with screwdrivers. So here you see the CAN bus, which is the communication with the battery. This one is your RS485. You can use this for lots of different things. Here is your meter. So if you're going to use a meter rather than using a CT coil, so if you've got very long runs, you use a meter. You can't use wireless meters if you're complying with G100. It must be a hardwired meter, a Modbus meter. So you can plug this in here. And then here, these two ports here for paralleling. So if you're going to parallel the inverters. On the connectors, please remember, now you see six connectors. There's no earth point on the connector. So you have neutral live, which is your grid, which is both in and out. You've got neutral live, which is your load, which is your essential load, and neutral live as the generator or the auxiliary. And then your earth point, and ignore, I've just screwed it on here. You need to put a lug on here, but your earth point mounts underneath it. So be aware about the earthing. Don't forget also, make sure you put your CT, you've got your CT coil. I've just got it connected on a lead, or as one of my friends in Australia calls it, a suicide lead, open-ended. So something to remember. What I keep saying is get familiar with it, understand the system. There's lots of things going on and lots of applications, but if you go to a site, don't get to the site and wonder how to program it. Look at the site. If you need to update it, you need to do anything, you need to add the dongle. Just familiarize yourself. You know, put it on the, this is in our office, but put it on the kitchen table, put it on anywhere. Just get familiar. Don't go to a site. The other thing is, always look for the latest instructions. And sometimes our products change, and this is a new model, and there's a few changes put on the instruction manual, so the instructions are not quite up to date, but they will be by the time you go online. So it's always like this. Look at the unit here. What I've done here now, I've set the unit to charge the battery, so it's actually charging the battery. And if I go on here, you can see I've got my battery charged, battery at 10 amps, and here this is actually an overall figure, but it's actually set at 10 amps. We're using a controller here, so it will take it to 100% SOC, state of charge. This is my control. I won't go through all the programming because I can do that in other things and more advanced things. I'm not going to go through everything else, but I just wanted to explain on this video, the most important thing of all is to make sure you have communication with the battery and the inverter, and make sure you're familiar with it. Understand what you need to do to charge the battery, understand what you need to discharge the battery. So it's quite important. I put lots of training videos up and showing about how to use it and how to do these settings, and there's loads and loads and loads of things, because often it's something silly and somebody gets to a site and can't say, oh, the battery's not charging, or the battery's discharging, or it's not doing it's often a very simple setting, because these inverters do absolutely everything. You know, if you want load, I showed a video today and earlier on today showing an application where we're using load shaving. So if you're limiting the amount of power coming into a building, then you can use that feature. You know, talking about that, there's also another great application for this, and you would consider it as an advanced system or not an advanced system. But one thing to bear in mind, if you've already got a grid system there, you've got a grid system, and I was at a site fairly recently, and they put in a 20 kilowatt on-grid system. And they said to me, well, it doesn't matter because we're using all the power. And this could be a massive system, it could be anything, but it's an on-grid system. They said, well, we use the power, we don't get any export tariff because the export tariff is already finished. So not getting export tariff, they've got a 20 kilowatt array, and they use typically 30 kilowatts a day. So I said, well, why don't you think about storage? He said, well, what's the point? There's no point in putting the storage in because there's nothing to store. But that's where they're wrong. Because, you know, I tried to explain, and so I put my board here, and I said, look, hold on a second. If you consider your solar production, so your solar production is going to be, and I'll use a different colour, my drawings are pretty bad, but we'll talk about that's midday, and our solar production is probably going to be something like that, is my solar production. So that's what I'm going to produce. Okay, and this may be, if I've got a 20 kilowatt array, so I've got a 20 kilowatt array, and it might produce myself 30 kilowatt hour power. So I'm expecting something like that. But my load over the same period is 30 kilowatt. So, well, fantastic. I've got no electricity bill, but you will. Because your load is not a flat load. If your load was that, then you would have here be maximum. But your load is more like over the period. Your load will be simple. Now I'm just showing it will be much more complicated than that. But the fact is, I'm using power here. I'm using power here. I'm using more power than I've generated here. I'm using more power than generated here. But this area here, this power, this here, is wasted. It's wasted electricity. It's wasted, it's gone. Because I'm not going to get an export tariff. There's no export tariff. And I produce that power from my array, but it's wasted. So what happens is if we store that electricity, the wasted power, and we use it there. So simple, add on a small storage inverter, a small hybrid inverter with battery, not big. If you put a 20 kilowatt array, you might only want to put a 5 or a 10 kilowatt battery. So it's a fairly small system, and you add it to your existing on-grid system, and hey presto, that inverter will be charged only off the surplus power, and it will save it. So you can look, if you look what goes through that inverter, and what power is going through it, it's all free electricity. Because if you're not exporting, you get zero for your export, and you're using an on-grid system, which a lot of people will do because it's cheaper. And by putting a small system in parallel, so it's AC coupled, so use our small system in parallel with your existing system, then it's a very cheap way of doing it. Of course, you can use our systems just to all fit into our inverters, but it's a relatively cheap way of doing it. So you can AC couple our inverter to a grid-tied inverter, an existing system, and that way can save you a lot of money. So it's just a bit of thought. I'm going to be doing some other training videos, some more advanced stuff very soon, and sort of some interesting things to do with motors, and we've got a load of questions now that's coming. I did ask people to send questions and answers and send it to Joel if they've got questions, but if you've got any more, please send it to you. And I'm going to do some more webinars next week, so I'm going to get on top of this because I fell behind. I apologise, and I had too much travelling and that, so we've got lots of things going on, so keep following, and we've got lots of things. And look at this. This is a nice little piece of kit. This is beautiful. It's really nice. You know, it's so light. I think I don't know the exact weight. It's less than 10 kilo. It's really, really nice, and it'll fit in anywhere. Match it with our battery. It looks the business. So thanks for watching. Bye.